Good morning, good afternoon, good evening. This is Michael Jansen, founder and CEO of Cityzenith. Thank you very much for giving us the opportunity to be a part of this event today. Adam Soroka and the crew at Future Digital Twin Oil and Gas. We are so excited to be here. We've been here, I think, at these events now for several years now, at least a few years, and we're super excited to participate in this one. And thank you for inviting us. So I was asked to talk today about urban digital twins, what those are, and how urban digital twins are kind of leading the charge for energy transition at scale, especially in the built environment. So urban digital twins are digital representations of the physical built environment in our cities, including transport networks, buildings, and infrastructure, and they're connected to the data in and around them. They're used to optimize all aspects of planning and design, construction, as well as the operations and maintenance of facilities, especially at scale. So we have a number of projects running currently around the world as part of an initiative that we launched called Clean Cities, Clean Future. Includes the rollout of urban digital twins in New York City, in Los Angeles, in Phoenix, and also here in Las Vegas. So please enjoy this video introducing our urban digital twin project in Las Vegas.
39% of global carbon emissions come from the buildings in our cities. Currently, less than 2% of America's 6 million office buildings are green. What if we could help buildings, infrastructure, and cities reach net zero faster, without risk, and at a fraction of the cost? At Cityzenith, that's what we do. Our Smart World platform leverages cutting-edge AI to automate the complex decarbonization process. Powerful 3D visualization tools help clients analyze and predict performance in real time, simplifying financial and operational decision-making. Thanks to our partnership with the City of Las Vegas, our Las Vegas Digital Twin features an unprecedented level of real-time sustainability data. Outside buildings, sensors monitor complex metrics, feeding data continuously into Smart World, including information about traffic density and air quality, helping planners, developers, and city officials make Las Vegas a more efficient, sustainable, and enjoyable city. Inside buildings, Smart World OS allows users to optimize their operational and energy systems, ensuring occupants enjoy a high-quality environment. Cityzenith's new Smart World OS Net Zero module continuously monitors clients' energy consumption, tenant behavior, and renewables performance, making it simple to purchase high-quality, verified carbon offsets to ensure properties maintain net zero compliance, providing the only true end-to-end net zero solution for building owners today. Cityzenith. We pledge to make the built environment a cleaner, safer, more efficient place for all. Join us.
So urban digital twins are uniquely powerful in that they have been assessed to help reduce operating costs by an average 35%. This is from an E&Y report on the subject, boosting productivity of at least 20%, but sometimes as much as 80%, depending upon the function that's being addressed. And now they're being used more and more as an avenue for exploring the mass reduction of emissions at scale. Now, Forbes recently noted that urban digital twins will be the mainstay for 500 major world cities within the next just few years, which is an incredible thing if you think about it. And that'll be massively transformational. I would even argue revolutionary in terms of how cities operate today. We will laugh at the way we use technology tools today once we're all using urban digital twins to operate cities at optimal efficiency. I think it was ABI Research who projected that cities will save $280 billion in planning, development, and operating costs over the next few years. And that's pushing the digital twin market from just a few $1 billion last year to predicted to hit over $50 billion by the year 2026. In fact, by 2027, now they're saying something like $62 billion. So it's growing at an incredible pace. The inconvenient truth is that buildings in cities are the world's largest polluters. Buildings themselves produce 75 to 85% of all emissions in cities, and I think according to the World Bank, 39% of total emissions globally. And three-quarters of buildings need to be retrofitted in order to achieve all the net zero targets that we have laid out for ourselves out there. We've seen now, I think, 1,000 cities make commitments to achieve carbon neutrality worldwide, thanks to the efforts of initiatives worldwide. I think this made it pronouncement at COP26, but yet it's astounding when you think that in the United States, of our 6 million office buildings, only 1.7% are green. So we have to basically decarbonize almost our entire existing building stock of 6 million buildings. And we today have, I think, fewer than 500 true net zero commercial buildings in the world. It might be like 1,000 or 1,500 now, but it's a low number. Long way to go. We think that cities can lead by example, not just American, but European, Asian, African, South American cities, I think, are all doing interesting things in this space. But to get to net zero from a building perspective, there's a few things that we have to do. It's not a switch that you flip. It is a process that you undertake, which involves installing sensor-based energy optimization equipment, leveraging renewables maximally, and then potentially acquiring carbon offsets or carbon rewards or carbon credits to offset the balance dependency that a building has on fossil fuels, whether those are oil and gas or others. And then it has to be continuously monitored and recertified every year for a number of years. So that process takes time. Now, there are a lot of positive drivers that are driving all of this, and in America especially, which is admittedly behind Europe when it comes to the kind of progressive energy policies for buildings and cities. But even here in the US, cities have begun to mandate that building owners eliminate emissions. New York with their Law 97, now the city of Boston, city of Washington, D.C., city of St. Louis, Ithaca, etc. So I think 6, 7 cities in recent months have now all made it law for building owners to eliminate emissions. With this new Build Back Better bill coming along, that's creating a $200 billion market for green building retrofits in this country alone, which is substantial. So the problem is that building owners generally traditionally have seen this as too expensive and too risky. Green building retrofits cost a minimum of $2 to $7 per square foot, as you may know. Energy costs in the U.S. for commercial office buildings average about $2.10 per square foot. So that's an entire year, a year's energy consumption. And typically, from a cost perspective, this type of undertaking can take something like 10 to 15 years to pay back. And the problem is that the top of the real estate ownership pinnacle is looking for investments or pyramid investments of that they can realize returns on within 3 years or less, and certainly not less than 5 years. They look seeking an internal rate of return of 30%, and therefore, because they're not even close, they just don't do it. And without laws to require them to do it, they generally just avoid. So a lot of the activity you're seeing in the retrofit space is really the big companies that have ESG and other budgets and can afford to do it, but it's just not being done otherwise. And that has results in us falling dramatically short of where we need to be in terms of spending on green building retrofits. It needs to triple to hit Paris climate goals and these various net zero target goals that cities have laid out over the next several years. One of the biggest issues is that the green building retrofit consulting process, if you now know what it is expensive, it's labor intensive, and it's risky. There really aren't any automated tools that make this easy for customers. There are thousands of single purpose energy management tools that have flooded the market, promoting proprietary standards and largely confusing building owners that don't know what to buy. And the result is that building owners don't make commitments to the substantial capital outlay because of all the uncertainty. So, when we looked at the problem, we decided that a lot of it is actually a data integration and a connectivity problem. That the data is there and the data can be used to inform owners what to do in a way which eliminates risk, which largely automates it and makes it a lot cheaper. So the platform that we've created from originally from the founders of Google Earth that we then took forward and built into this unique entity that is today is called Smart World OS. And Smart World OS is an urban digital twin platform that aggregates a tremendous amount of information, allows that information to be visualized in powerful ways so that multitudes of users with different skill sets can all use that data in ways that is very effective for them and allows us to use that data to create a whole new generation of artificial intelligence and machine learning based analytics like we've never seen before in cities. If you look on the right hand side, you see all the tools and software tools that kind of come together to create the reality for our practitioners in cities today: BIM, CAD, GIS, IoT sensors, you name it. And there just aren't tools that allow you to do these key things. The digital twins generally have to achieve four things at an urban scale very successfully. They have to be uniquely good at aggregating all of this data. They have to be uniquely good at helping you to visualize all this because this data has a multitude of formats from machine learning, excuse me, from machine reads, which you'd find in an IoT sensor configuration, to things which are BIM files or three-dimensional files. Now, how do you extract the data from that into a common context? And that's what's unique about urban digital twins. Effectively, we're able to overlay this data graph on top of all this chaos and make geometric and mathematical sense out of that so we can run any types of simulation. That's the power of it and why it's becoming such a powerful tool around the world. Digital twins help to aggregate and simulate all that complex data, and decarbonization is a complex process. It allows us to predict energy consumption, leveraging all that data at scale, as well as the financial metrics. For example, we make recommendations leveraging digital twins that can say, we suggest that you use this equipment, that you can leverage these renewable strategies, and that you can indeed leverage these financing strategies. And those could include anything from carbon offset based financing to state, local, and federal incentive schemes. So the ability for a digital twin to be able to study all these things in parallel, the impact of a BMS on a solar system, on a geothermal system, on a financial strategy, all at the same time, is its unique power. And then to be able to monitor that, because digital twins are space-time based, they're space plus time. So to monitor that over time and to be able to make the adjustments on the fly that are necessary to maintain those metrics, that's what's absolutely key, and why digital twins, I think, are the only technology that can really deliver this. So, we've been working in the spectrum of energy transition in the built environment: property owners, facilities managers, infrastructure operators, energy firms, architects, engineers, planners, governments, etc. And we think that the types of projects we're focusing on tend to be larger scale: airports, seaports, infrastructure, utilities, entire real estate portfolios, districts, like you'll see in LA shortly, entire cities sometimes, which is unique in that right now a lot of the focus is kind of on single entities. And by developing a tool that was the most advanced of its kind, very flexible and scalable, able to go pan life cycle operationally from design through management, and then build a community around that. We recently joined the World Economic Forum's Net Zero Carbon Cities group to help implement this initiative in cities around the world, which we're very proud of. We do all kinds of things. We do large-scale projects, like I mentioned. We have partnerships with large-scale companies like energy providers, is I think, our favorite these days. And then we have a model, kind of a platform model, which allows us to create a simple web-based module of this for building owners of any scale, really anywhere. So we kind of tackle both the top and the lower end of the market at the same time, as well as the middle. And we've done a bunch of things. Right now, we're working in Las Vegas on a project. We're working in Phoenix, and that's with Amazon. We'll be hearing a lot about that soon because we'll be making the first announcements. All these projects are focused on using the geospatial element of our product to identify the decarbonization opportunities using data, and then leveraging the desktop client-based element of our product to drill down and find solutions for individual owners. Our project history has been fairly extensive in the urban digital twin space. We've done 15 or 20 major global projects, including things in downtown New York with Cushman and Wakefield, things with W.S. Atkins and Langer Workout in the UK on a big infrastructure project, a rail project, and entire new cities in South India with Sir Norman Foster of London. We welcome the opportunity to work with new partners, especially from the oil and gas sector. We have many conversations going on right now. We are a perfect fit for those companies seeking partners that can do what we do in the energy transition space, and we welcome those conversations. Thank you very much for the time.